what is the difference between thermodynamics and heat transfer? See, the very first and foremost difference is thermodynamics deals with the laws related to energy. It deals with energy. And in energy, we have everything. We have a stored form of energy, that is kinetic energy, potential energy, chemical energy, nuclear energy. And we have also transit form of energy, which is not energy, but the mode of transfer of energy, which is heat and work. So thermodynamics deals with energy, including everything that we have studied so far in energy. But in heat transfer deals with heat only. It deals with heat only. Now, next difference, in thermodynamics, we are interested in energy conversion. We want our one form of energy to be converted into another form. For example, this is our engine, and when we supply heat as input, it gives us work and output. So this is our transformation. And also, if you see the boiler, when I supply chemical energy to it, it converts that chemical energy into heat energy. Similarly, if I talk about let's say turbine, so it converts kinetic energy into mechanical energy. So this is our transformation. Now, what do we do in heat transfer? See, as the name suggests, it is transfer. We deal with the transfer only. Now, this is different from transformation. In transformation, one form of energy is converted into another form of energy. But in transfer, the heat is being transferred, not other forms of energy, because we are dealing with heat only. So heat transfers because of temperature difference. So let's say we have two bodies, hot and cold. So what we will see? We'll see that heat is now transferring from hot to cold body. So this is the heat transfer. And also in heat transfer, we study because it is not the energy, it is the mode of transfer of energy, right? So therefore we study the various ways by which the heat can be transferred, that is conduction, convection, radiation. Another difference, in thermodynamics, we are interested in knowing, in calculating the amount of any form of energy, the amount of energy given to the system or taken out from the system. But in heat transfer, we are studying the rate of heat transfer by which it is transferred to the system or to any body. So now in thermodynamics, as we see, when there are some energy conversion taking place within the system or outside the system, or whatever you can say, into the system or out from the system, whenever there is some energy conversion taking place, what happens is that the system that I have, its properties, there are so many properties like pressure, volume, temperature, enthalpy, entropy. So these properties, they change, and when they change, I have to define my system at equilibrium. So this energy conversion, when happens, then I study my state, my system at a particular state, that means at equilibrium. So in thermodynamics, if I talk about the next difference with respect to system, then I study the state of system. But in heat transfer, I study the temperature distribution inside the system, right? Temperature distribution inside the system. Let's say this is my body that you would have seen while you were studying heat transfer. So let's say the heat is transferred to it through convection, and when the heat flows inside it, so you could see the drop in temperature. So this is our temperature distribution inside the system. Across the width, there is dropping of temperature. So this is how it goes. So this is what we study in heat transfer. Next difference we can have, in thermodynamics, we deal with any potential gradient. What is this potential gradient? See, any potential gradient means for heat to flow, I need some temperature difference. For work to happen, I need datum difference. I've done work on the system to raise it to some height, then it has some potential energy, and that is because of datum difference, right? So that temperature difference, that datum difference, right, these are potential gradient. So we deal with any potential gradient in thermodynamics, whereas in heat transfer we deal with temperature gradient only. As you have seen here in the diagram.